Welcome back, everyone. So in this video, we're going to explore the power of the Lewis dot structure with regards to compounds, specifically compounds that are ionic and covalent. So actually in this video, we're going to focus more on compounds that are ionic, but I wanted to refresh your memory on the difference between ionic and covalent bonds. In covalent bonds, or molecular compounds, which we'll talk about in subsequent videos, those molecules are made by the sharing of electrons to make a bond. Whereas in ionic compounds, you have ionic bonds where you have the complete transfer of an electron from one species to another to form a molecule. So what we're going to do in this video is investigate more how a Lewis dot structure can help us predict what kind of bonding happens in an ionic molecule. So if I was to ask you what the correct chemical formula was for KCl, potassium chloride, even without this Lewis dot structure theory, you could give me the correct answer. We've talked about how to do that. You would look at your periodic table, which you should have handy next to you, and you would see that potassium is K, and it's in group 1, and you needed to memorize from a few chapters ago that potassium likes to be a +1. Chlorine's in group 7. Those guys like to have a -1 charge. And so putting these two ions together to form a neutral molecule, you would have KCl. And so that would be the correct chemical formula for that ionic compound. But we can also use this Lewis theory, Lewis dot structure theory, along with the octet rule that was introduced in a previous video to correctly predict this chemical formula of KCl and other ionic compounds. So if I was to ask you what the Lewis dot structure for an individual potassium atom was and an individual chlorine atom was, you should be able to tell me, well, I know the Lewis dot structure for just potassium. Potassium is in group 1, so it has 1 valence electron. Chlorine's in group 7, so it has 7 valence electrons. And so remembering this octet rule that atoms like to beg, borrow, steal, do whatever they can to have a total of 8 valence electrons in their outer shell, you can clearly see that chlorine would love to have an additional electron. If chlorine had an additional electron, it would then have 8 valence electrons around it. Well, here is potassium with its 1 valence electron, which it would gladly like to donate to chlorine, because when potassium does that, when it donates that 1 valence electron, if you look at your periodic chart, if potassium loses an electron, it then has the same number of electrons as its previous closest noble gas, which is argon. So for potassium to donate, completely transfer that electron to chlorine, makes potassium happy. It makes chlorine happy with regards to the octet rule. And that is indeed what happens. So we can write in Lewis dot structure notation, the Lewis dot structure for this ionic molecule of KCl in this way, where we have the potassium as a positively charged species because it lost that electron, so it's a cation, and chlorine, since it has gained that electron from potassium, it is now negatively charged, so it's written as an anion. And the way that the notation works for this is that positively charged species in Lewis dot structures have the plus charge. The species that gains the electron shows all the electrons, and it's put in brackets and has the appropriate negative charge associated with it. So Lewis dot structure can help us predict correct chemical formulas for ionic compounds. It works for potassium chloride. It also works for the ionic compound magnesium oxide. So if I wanted to predict the correct chemical formula for magnesium and oxygen, here's my Lewis dot structure for magnesium. It's in group 2, so it has 2 valence electrons. Here's my Lewis dot structure for oxygen. It's in group 6, so it has 6 valence electrons. And so you could see that oxygen would love to have those 2 electrons that magnesium has. That would give it an octet. If magnesium loses 2 electrons, if you look at your periodic table, if magnesium loses 2 electrons, it will have the same number of electrons as its closest previous noble gas, which is neon. So we can say that the correct ionic compound formula for magnesium and oxygen is just MgO. And again, magnesium is going to have a +2 charge because it lost 2 electrons. Oxygen gained 2 electrons, so it's going to have the -2 charge. And it's in brackets because of the notation for Lewis dot structures and anions. Okay. So in the next video, or I recommend you could try it yourself, but we'll go over the answer in the next video. In the next video, we're going to talk about how we can use Lewis dot structures to predict the ionic compound formed between sulfur and sodium.